Hello and good day, geometry. Today we are looking at CO46, which is using all properties of a rhombus in various contexts. So in CO45, we kind of talked about the characteristics of a parallelogram. And there are actually kind of three shapes that fall in the parallelogram category. The first one we're going to talk about is a rhombus. The next one we'll talk about in CO47 is a rectangle. And we'll wrap things up in PO48 talking about a square, okay? So all three of those shapes, because they're parallelograms, have some of the characteristics that are the same. And then each of them have some different characteristics unique to them that kind of separate them from the other two. So CO45, we were talking about the broad parallelogram family. And now starting in CO46, we're going to kind of focus on one of those types, which is the rhombus. And the five characteristics that a rhombus shares with a rectangle and a square, because they're all parallelograms, are the following. And you should recognize these. Both pairs of opposite sides are congruent. Number two, both pairs of opposite sides are parallel. Number three, both pairs of opposite angles are congruent. Number four, adjacent angles are supplementary. And number five, the fifth characteristic that all parallelograms have, the diagonals bisect each other. And you've got all five of those characteristics outlined in CO45. So it probably should have done this originally, but it's making sure that we're all on the same page as far as what a rhombus looks like here. A rhombus, it's similar to a square in that all four of its sides are congruent. But what makes it different from a square is that it does not have those right angles. So if you imagine like you got a cube of Jell-O sitting on a plate, right? A cube of Jell-O sitting on a plate. And if you were to shake that plate, what's going to happen with the Jell-O, right? It's going to wobble back and forth. The side lengths of the Jell-O don't change. They just move from side to side. So whereas this would be a square, what I've drawn here, a rhombus is going to look kind of like this. Okay, similar to the parallelograms that we were drawing yesterday, but the difference is that it does have all four sides congruent. So going down now below here, what separates a rhombus from other parallelograms, what makes it special, is that all four sides are congruent. Okay, that's what makes it different from a rectangle, right? A rectangle, it's got two pairs of sides of different lengths. The next one, not only do the diagonals bisect each other, but the diagonals are perpendicular to each other. Okay, the diagonals are perpendicular to each other. So drawing a picture of this one, draw a little rhombus down here in the corner. Best as I can. Remember, I did fail art, so there we have it. Okay, so the diagonals, because it's a parallelogram, they're going to bisect each other, meaning that where they intersect, right? That's going to kind of be the midpoint of the diagonals. But furthermore, because it is a rhombus, they are perpendicular, meaning you've got a right angle here, okay? Which means that inside of a rhombus, what do the two diagonals create? I said we'd be taking a break from triangles for a while. I guess I kind of lied because inside of a rhombus, you have 4 right triangles that are formed by the diagonals when they intersect, because those diagonals are perpendicular to one another. So we will be using things that we learned in Unit 6, Pythagorean theorem, sine, cosine, tangent, 45, 45, 30, 60, 90 triangles to help us get information about the parts of a rhombus, but we'll get to that in a little bit. And the third thing is that, again, with the diagonals bisect each pair of opposite angles. The diagonals bisect each pair of opposite angles. So going back to our picture of the rhombus that we just drew here, okay, the diagonals bisect each pair of opposite angles. It means that this angle is going to be congruent to that one. This angle bisected congruent angles there. And down below our other angles, we have the same thing. Okay, so a lot to do with the diagonals when talking about a rhombus. Not only do they bisect each other, they bisect each pair of opposite angles, and they intersect at a 90-degree angle because they are perpendicular. Okay, so you've got 8 things you need to know about a rhombus. The first 5 are true for every parallelogram, and because a rhombus is one, then those 5 things are true for a rhombus as well. And then these next 3 are kind of special to a rhombus. Okay, so let's look at a rhombus down below and see what we have here. It says, use the diagram of rhombus ABCD to answer the questions. And we're not going to go over all of this because this is going to be your homework. Nothing from the textbook for this one, just this page here. But knowing this is a rhombus, there's a lot of information that you can already gain from this. You know that AB is congruent to BC, is congruent to CD, is congruent to DA, right? All 4 sides are congruent. You know that the diagonals in the middle, like DE is going to be congruent to EB, and AE is going to be congruent to EC, right? Because the diagonals bisect each other. You know that the angles are bisected, right? So all 4 of these angles are congruent. You don't have any measures given for these 4 here, but they're all congruent as well. And you also know that the diagonals intersect at a 90-degree angle, meaning that you've got 4 right triangles within the rhombus. So let's take a look at this here. The first one says, what is the measure of angle DAC? All right, DAC is this angle right here. We've already talked about that angle, right? Because it's a rhombus, and because the diagonals bisect each pair of opposite angles, if angle CAB, the one that's adjacent to it, is 53, this one is going to be 53 as well, right? So DAC 53 degrees, okay? Then it asks for what is the length of DB. Now DB is the entire diagonal all the way from D to B. We know that this part from D to E is 8, and we also know that the diagonals bisect each other, so we know that E to B is the same distance as D to E, meaning that E to B is also 8, which means that DB is 16, right? All I'm doing here is I'm taking the relationships, the characteristics of a rhombus, and applying them to the information that I'm being given. Okay, you can do the same here. Even though you're seeing these things for the first time, if you're asked about DB, and you know that DB is a diagonal, look up at the top of the page and say, okay, what do I know about diagonals? I know they bisect each other. I know they bisect each pair of opposite angles. I know they intersect at a 90-degree angle. What's going to help me here? What's going to help me here is knowing that they bisect each other. DE is congruent to EB, and we got to 16. All right, let's look at some of the other ones. What is the measure of angle AED? AED is right here. What do we know about that angle? Okay, it's an angle that's formed by diagonals. So again, you want to look back at the top and say, okay, what do I know about the diagonals? Which characteristic, which property can help me find the measure of AED? What is the measure of AC? AC is the other diagonal. Okay, and we're not given any information about side lengths or diagonal lengths for AC. However, in the first question, we did figure out that DAC is 53. Spoiler alert, AED here, the one we did previously, is a right angle. So what do we know? I know I've got a right triangle, triangle ADE. I know one angle, 53. I know one side, 8. Is that enough information to solve for this piece here? Because if I get that piece, then from there, I can calculate the length of the entire diagonal. So what method would you need to use to solve for that side AE? Well, you've got a right triangle with one side and one angle. I'm thinking sine, cosine, tangent here. Make sure your calculator is in degree mode. Okay. Then the measure of angle ADC. ADC is this whole angle here. Okay. How can you get that? From the information you've already been given or what you've already solved for. Then what is the length of AE? That kind of ties directly with AC there. What is the length of AD? Again, this time you're looking for the side of a rhombus. Well, once you find AE, which you're using sine, cosine, tangent for, you can either then jump to the Pythagorean theorem to get the hypotenuse of that right triangle, or you can sine, cosine, tangent again, right, to find that missing side. And then finally, at $2.65 per unit, how much would it cost to install a fence around the perimeter of rhombus ABCD? So knowing what AD is, and then knowing what the properties, what the relationship between the sides of a rhombus is, you can calculate the perimeter, and then at $2.65 per unit, how much would it cost to put a fence around there? Okay, so there's absolutely zero new math here. This unit is all about using the math we've already learned and apply it to new relationships. The new part in CO46 would be the relationships of a rhombus. Okay, all the math, all the calculations, we've done that before. Now it's recognizing, what do I have here? What does that mean? What can I use to get the information that I want? All right. So rhombus, there you have it. This is going to be due on Monday when we meet again for a live lesson. Thanks for watching. Have a great day. If you got questions, don't hesitate to contact me, and I can help walk you through it. But have a great day. Don't forget to like and subscribe.